A 2.10 meter radius, 351 kilograms, cylindrical. They're all cylinders. Spinning at 75 RPM, slows to a halt in 11.5 rotation. Okay, so clearly we can find an angular acceleration from that. And then we want to know what force applied tangentially at the edge would cause this. Okay, so here we go. Torque is I alpha. Okay. Let's see. We've got cylindrical, right? So this is definitely going to come from 1/2 mr squared. And m is going to be 351. Whoops. And r is going to be 2.1. Okay. And then ultimately we're going to find a torque, right? And then that torque is going to be r times f. R is going to be 2.1, and F is what we want to find. Okay, so let's see. I think we got to find this too. So torque is I alpha. Okay, so let's find this guy first, just because it's easy. So 0.5 times 351 times 2.1 squared is 773.955. Okay, now we got to find alpha. That's going to be tough. So let's see. Omega theta, omega initial, omega final, alpha t. Let's see. 11.5 rotations. So 11.52 pi's. Okay, it's to a halt. The final velocity is 0. Initial velocity is 75 RPM. So 75 2 pi's in 60 seconds, right? 75 rotations per minute, right? Got to turn into radians per second. Okay, and then we want to find alpha. So I guess what we're going to use is omega final squared is omega initial squared plus 2 alpha theta. Alpha is omega final squared minus omega initial squared over 2 theta. So it equals 0 squared minus 75 2 pi's over 60 squared, right? All of this divided by, oh, I can't fit it in there. Okay, let's do it here. Let's see, 0, it's 0 squared minus 75 2 pi's over 60 squared divided by 11.52 pi's. 2 of those, right? 2 theta. This is theta right here. Yeah? Okay, so let's see. What's my acceleration? I'm just going to go parentheses 75 times 2 pi divided by 60. Okay, so I've got that squared. All right, so 0 minus that squared divided by 2 divided by parentheses. 11.5 times 2 pi. Okay, so my deceleration is, I guess, negative. I'm just going to kind of ignore that minus sign here in a bit, though. 0.4268 radians per second. Okay. So you can, of course, you can just bust these out and then toss those in there. I'm just too lazy to do that. Right, but those are the conversions, right? Then use this formula. Pretty sure that's the right answer there. So now I'm going to plug that in here. 0.4268. I'm ignoring the minus sign because we just want to know the force at the edge, and I don't know how to deal with a minus sign there. So I'm going to multiply that 773.955 by the acceleration I just got, and I've got the torque is 330.36. Okay, so torque 330.360 something, right? Right, and if that equals R times F, right, we go RF equals 330.36, right? Then 2.1 times force equals, I just divide 330.36 by 2.1, so divide by 2.1. I get 157.3. Ta-da. So what were my steps? My first step was I found the moment of inertia. That's easy, right? 1/2 mr squared. It's a cylinder, right? And all those little moments of inertia will be on the top of the page, right? So first step, find the moment of inertia. Ta-da. Second step is solve the kinematic problem, right? Giving it to you in RPMs and all that stuff, because to do any less would be insulting you, right? So convert the rotations to radians, RPMs to radians per second. Solve it for the angular deceleration in this case, right? And that's radians per second squared, right? Third step, use torque as I alpha to find the torque, right? Which is this. And the fourth step is to take that torque and the radius and figure out what force at the edge would do that. 157 newtons at the edge, right? All right. It's always 4 steps.